Hello, this is Mr. Precella, and today we're going to be discussing how to solve quadratic equations. And you might be thinking, well, wait a minute, we did that the last time. And you're right. We solved quadratic equations by factoring. And we said a quadratic equation is an equation. By equation, we mean there must be an equal sign in it. So it has to have an equal sign. And it can be written in the form ax squared plus bx plus c equals 0. X is the variable, a, b, and c are numbers, but if there's got to be an x squared term, then we need to make the stipulation, if this is going to be a formal definition, that a can't be 0. B and c can be 0. A can be any number except 0. Okay? And we solve some equations by factoring. And to do that, you have to have it written in that standard form with a 0 on one side. Usually we write it with a 0 on the right, but theoretically there's no reason why it couldn't be written like this. Ax squared plus bx plus c. Instead of saying equals 0, you could have the 0 over there on the left. Sometimes when students have an equation like this with a 0 on the left, they're like, oh, I don't like that. And I always tell students, if you just don't like the 0 being on the left, just mark it out and write equals 0. It's the same thing. Equality is reflexive. A equals B means B equals A. So that's going to be the first step that we were doing when we were solving equations on Wednesday. This is going to be our first step today. We've got to make sure it's in standard form. Then factor. Set each factor to 0 and solve. And we were doing this trial and error factoring. So this is how we ended the class the last time. And it's actually how we're going to begin it today. Problems 1, 2, and 3 in our homework assignment. Well, first of all, remember you got to check all these videos. We went sort of crazy putting videos. We have 3 different videos of ourselves from previous semesters working these examples. And then we have Elaine Martin Gay doing 2 lectures from Pearson. Problems 1, 2, 3 is exactly like what we were doing the last time. And I thought we'd do problem number 2 to get started. It says solve by factoring. Let me write it down. And if you're thinking, wait a minute, you didn't show us anything new before we got started. Yeah, you're right. I'm literally picking up where we were the other day. Solving quadratic equations by factoring. We're going to see some other methods today. Okay. So to solve it by factoring, is that equation in standard form? Yeah, it has a 0 on the right. Great. And then it's y squared, y, constant. Constant is what you call a number that doesn't have a variable in it. Okay? In our formal definition, the constant would be the letter C. Okay? So we have a 0. It's in standard form. So let's factor this thing. I think, okay, numbers that multiply together to give 2. Well, there's not a lot of possibilities, right? 1 times 2. And if you're sitting there thinking, oh, that idiot, there's a lot of possibilities. 1/2 times 4, 1/3 times 6. When I say numbers, I mean counting numbers. Okay, today. Let's see, what are the numbers that multiply together to give you 22? Well, there's 1 times 22, and there's another pair. What is it? 2 and 11? Hey, remember I made a table to help y'all with the factoring. You remember how that went? This second sign is minus. So what type of numbers multiply together to give negative? What are we going to have in the factored form? 2 pluses, 2 minuses, or one of each? Second sign is minus. You'll have 1 plus and 1 minus. So let me go ahead and draw my 2 sets of parentheses. So that equals 0 that I'm carrying down. Since there's one of each, I'll wait to fill them in because I'm not sure whether the plus should go in the first set of parentheses or the second. So, but I do know one thing, 1 times 2. So y times 2y, is that how y'all would put it? Now, it's now just a matter of trial and error, but it's not just random trial and error. Here are the only numbers we can be using. I'm going to start with the 2 and 11, and if those are going to work, there's really only one way to arrange them. Could I put the 2 with this other 2 here? No, you can't have a common factor other than 1 in the parentheses. So you couldn't put a 2 here. In general, you can never have 2 of the same number in the parentheses, or say 2 even numbers. You couldn't do that. So I'm going to try it with the 2 here and the 11 here. If you're thinking, well, wait, that's what we were doing the last time. Yeah, that's right. That's right. Now I'm going to look at these little marks I make here is just how I check the outer and inner terms. When I'm foiling out, I know first would give me the 2y squared. Last gives me the 22. So these green marks, that's the outer. That would be an 11y. And the inner, would that be a 4y? So I want a negative 7y. Again, thinking back to that student from 1992 that told me, you're just making these things work out. That's right. How do I arrange this plus and minus so I'll get a negative 7? Okay, the 11 would have to be negative and the 4 positive. So up here, did y'all hear that? Put the plus on the 2, the minus on the 11. Foil it out to see, did I get the correct? Did I get 2y squared minus 7y minus 22? And then once you factor these, just set each factor to 0. What we've done now is we have 2 linear equations. A linear equation has no exponent in it. And to solve a linear equation, you perform the opposite operation to both sides, beginning with addition and subtraction in order to eliminate the variable. To isolate the variable. What would I need to do here to isolate this y? Yeah, subtract 2. So our first answer, it looks like y equals negative 2. When I say first one, I just mean it's the first number I found, the first answer I found. Now what about this one over here? What would I need to do? Add 11 to both sides. So we have just 2y equals, it's going to be positive 11. And now what do I do? Divide by 2. Good. So I'm going to go ahead and circle these answers, because if I didn't, and my brother came in, he'd be like, circle those answers so they know what the answers are and they know that you're finished with them. Negative 2 and 11 over 2. Those are our 2 solutions. Any questions before I type them in? Oh, notice here, the last time it would say x equals or y equals. Well, it doesn't on these. It says the solution is or are. There's 2 of them. Negative 2, comma, 11 over 2. I'll just type 11/2. Okay. Any questions there? The first three problems are just this factoring stuff. Problem 1 is really, really easy to factor. Problem 3, they've done all the factoring for you. It picks up with 2 sets of parentheses equals 0. So let's discuss other ways of solving quadratic equations instead of just factoring. Because there's a problem with factoring. Could y'all solve this equation by factoring? Suppose we had this quadratic equation. X squared plus 100x plus 1 equals 0. Is it possible to factor this thing by our factoring rules? Is there any way we're going to get a 100 in that middle term? Just no. Because all you could do is what? If you're going to try to factor it using our rules, 1 times 1, x times x, and what signs would we have? Both plus. So if we FOIL this out, we're not getting 100x as our middle term. What are we getting? 2x? There's just no way this can be solved by factoring because it can't be factored. Hey, and we had another word for can't be factored the last time. Do y'all remember what that word was? Prime? Yeah. So the natural question is, well, wait a minute. If we can't solve it by factoring, what can we do? Well, there's a lot of methods. We're going to see 2 other methods today. The first method we're going to see, new method. Well, by new method, I mean I haven't discussed it in class, okay? It's not new to the world of math. We're going to look at something called the square root method. And the square root method, I think you might be able to figure it out just by looking at an example. Remember, our definition of quadratic equation says there has to be an x squared in it. Suppose we had an equation in this form. X squared equals 36. This is one of those that if you know your multiplication tables, you can think your way through. What number times itself would give you 36? 6. Okay? Now, let's suppose I told y'all, generally, if the variable is a square, there's usually 2 answers. That's something called the fundamental theorem of algebra, and whatever the biggest exponent is, that's how many answers you should expect when solving equations. So there's an x squared here, so there's another solution here. I'll give you all a hint. One solution is positive 6. Another one would be negative 6. Negative 6 times negative 6 would give you a positive 6. So we would say on this one that I just made up, x is plus minus 6. So what did I do going from here to here? Well, to go from x squared to x, it looks like I just dropped the square. Is it too low? Can y'all see that? And then from here to here, you take the square root of the number and put plus minus in front of it. So take the positive and negative square root of 36. So let me go ahead and I'm going to state formally what this square root method is. Okay? if the equation is in the form x squared equals a number, then x is the positive and negative square root of that number. If you have the equation x squared equals a number. Well, let's look at number 4. Okay, number 4 says 5x squared equals 15. Let me write it down. $5x squared equals 15. Checking to make sure I didn't miscopy it. Well, there's a problem, or there's something wrong with this equation. If we're going to do this problem the way we did this is what I made up here, the x squared equals 36, we want to get rid of that 5. We just want x squared equals a number, not 5x squared. So there's a little bit of work we have to do first. What could I do to cancel out this 5? I'll give you an idea, or I'll give you a hint. Am I going to go minus 5 on each side, or divide by 5? Yeah, divide both sides by 5. And we have x squared equals 3. Now, 3 is not really a perfect square, is it? But don't let that panic you. You can still do what we did over here, or up here. You drop the square on the left and take the positive and negative square root of the number on the right. That's how we started the semester, with simplifying square roots. Can I simplify the square root of 3? No, there's nothing you can do to simplify the square root of 3. So there's your answer. Plus minus square root of 3. You might be thinking, well, wait, why are you leaving it like that here, whereas over here, well, we knew the square root of 36. Don't leave it as plus minus square root of 36. If you can simplify the square root, simplify. So I type in, way back, it might be 10 years ago or maybe 8 years ago, Pearson didn't have a plus minus key. Okay? And if you wanted to type positive 13 and negative 13, you had to type them in separately using a comma. But they finally got a plus minus key on here. I remember the first time that ever happened, when I was working this assignment and saw the plus minus. I was just so ecstatic. But the students thought I was insane. But just click plus minus square root of 3. Now, a word of warning. You're going to be they'll keep writing up the answers as square root 3, comma, negative square root of 3, rather than that plus minus, if you're looking at a viewing example or something like that. But we can use the plus minus, okay? Any questions there? See what I did? So you've got to have it in that particular form, x squared equals number. So let's see. Oh, well, look at number 5. It's not in the form x squared equals number, is it? Okay. 5x squared plus 35 equals 0. Well, We know how to do this one up here, number 4. The most basic problem-solving strategy is if you know how to do one. Wait, did I miscopy that problem? I sure did. Don't look at that. Okay, my brain is working slow today. 5x squared plus 35 equals 0. Later I'm going to watch that video, listen to it, and see, did I read it correctly? Did I read the problem as 5x squared plus 35 equals 0 when I was writing it down? Or did I say what I'd written, which was wrong? Okay? Here. 5x squared plus 35 equals 0. The most basic problem-solving strategy is if you know how to do one problem, and you're confronted with a new one, make it look like this one. So in terms of problem 5, let's see if we can make it look like number 4. We know how to do it if it says 5x squared equals a number. What am I saying we need to do? Okay, subtract the 35 minus 35 from both sides. Very good. I think the last time I mentioned that sometimes instead of saying minus minus, I'll just do these little arrows. Okay, subtracting 35 from each side. So we'd have 5x squared equals negative 35. Now is it similar to number 4? Oh yeah, what am I going to do to get it in the form x squared equals a number? Divide by 5. And we have x squared equals negative 7. X squared equals negative 7. So now let's get the x by itself, or get rid of that square. What you're basically doing is theoretically taking square roots of both sides. So if x squared equals a number, x is plus minus the square root of that number. Be careful. I'm dropping the square, and then I'm going to use this. Plus minus the square root. Now I'm going to color code everything. I'm going to make the negative a purple, which you might not be able to tell. It might look like black to you. And then I'll make the 7 black. Yeah. Plus minus the square root of negative 7. I'm not going to just type that in. The square root of 7 can't be simplified, but there is one thing we can do. Rewrite that negative as I. Okay. So we're going to rewrite, since it's the square root of a negative, this purple minus, which looks like a black minus, is going to be a purple I. So we write plus minus I, and then just leave the square root of 7 under there. If there's a negative under a square root, you never write it leave it like that. You put an I and remove that minus. This negative right here became this I right there. And this seems like a perfect time to mention algebra builds. Hopefully you've noticed that. Okay, I think it was the second lesson that we were defining complex numbers, imaginary numbers. And there we are using it now. Okay? That's why it's important that you go through all of this stuff in order. Okay? So plus minus I square root of 7. Okay, so I click in there, then I get the plus minus. I suggested that you put the I in front of the square root. Okay. Plus minus I square root of 7. Any questions there? This is called square root method. Now notice, this square root method can it solve every quadratic equation? Well, no. Okay? If you had something like could you solve something like 5x squared equals 35x using the square root method? No, you can't do that square root method if there's an x term. Okay? It's got to just have an x. I mean x squared, no x. So for something like that, you can't use square root method. Now, I've said that the equation needs to be in the form x squared equals a number. Really, as long as it's in the form something squared equals a number. If it's in this form, you can always use the square root method by dropping the square on the left, and on the right, take the positive and negative square root of the number. Now, why on earth am I mentioning that? Well, if we look at number 6, that's number 6. Oh, this is a multiple choice one. Well, we'll pretend those multiple choices aren't there. Okay, 2x, this is problem number 6. 2x minus 4 all squared equals 23. 2x minus 4 all squared equals 23. Well, can we use the square root? I don't think it does tell you use the square root property. Okay. Well, how? Well, it's in this form I have right here. Something squared equals number. So let's drop that square. On the left, we're just going to write 2x minus 4. And on the right, we'll take the positive and negative square root of 23. When I write a square root of a number, I ask myself, can I simplify that? Is there any way I can simplify square root of 23? 4, 9, 16. There's no perfect square that divides into 23. In fact, 23 is a prime number. So, are we finished? No. We want our answers in the form x equals. Okay? X equals. So, well, let's get this in the form x equals. It's going to look sort of strange what I'm doing. I'm trying to isolate this x. So what would I do first if I wanted to get rid of this x? Add 4 to both sides. I'm going to do that little thing I do with the arrows. So on the left, I just have 2x, and I'm adding 4. So I'm going to put that 4, a positive 4, in front of the plus minus square root of 23. And now what do I do? Divide both sides by 2. And at first glance, it might be tempting to say, hey, 2 goes into 4 2 times. But if you're going to do that, you have to separate it. Let's look at how, and that's what we did with imaginary numbers. We do the separation thing. But let's look at this one, how are they doing it? It's multiple choice. You see, they left it all as just one big fraction. Glancing through A, B, C, or D, which one is it? Is it A? Yeah. It's not B or C because there's not, they don't have the plus minus symbol in it. And it's not D. What did they do incorrectly on D? It looks like they may have subtracted the 4 and 23 to get a 19. Let's do one that's not multiple choice. I think the next one's not multiple choice. Maybe I'm wrong. I am wrong. Okay. Okay. Z plus 6 squared equals negative 15. Z plus 6 squared is equal to negative 15. Well, we know we can do the square root method if it's in the form something squared equals a number. I think number 7 is pretty similar to number 6. What am I going to do? Drop the square and just write Z plus 6 equals, okay, we have positive, negative, square root of negative 15 I'm using the colors here because there's a little bit of simplifying we have to do here on this square root. We can't simplify the square root of 15. But we can turn that negative into an I. Did y'all hear that? So on the right hand side I have the red plus minus. And I'm about to write a blue I because I'm saying this blue negative symbol here is what gives us that I. And then we have square root of 15. But we're still not done. If you're solving an equation, it should be in the form variable. Your answer should be variable equals number. Speaking of such, I should have circled that. One thing to do. What am I going to do to get the Z by itself? Subtract 6 from both sides, or move the 6 over and change the sign, however you want to think of it. We'll write it as negative 6 plus minus I square root of 15. Negative 6 plus minus I square root of 15. Oh, this is one of the more... Hey, I want y'all to look at... can y'all see right here? It's not lit up yet. Final check. But as soon as you click on one of these, that means this is only going to let you... if it's free form, you usually get 3 chances before it says it's wrong, gives you the red X, and you have to say choose another or work a similar problem. But which one of these? Well, heck, I think it's got to be A. And if I got it wrong, I'm going to have to say similar problem. You only get one guess, if you will, on a multiple choice. Okay? And the student wrote me and said that it says you have infinite number of attempts, but it's making them, it counted it wrong. Well, you can rework a similar problem. That's what it means by infinite number of attempts. Okay? So I'll say final check. Okay? So the square root method can solve particular quadratic equations. Those in the form parentheses, that you can write parentheses squared equals a number, or x squared equals a number. It wouldn't work on something like this. 5x squared equals 35x. Also, with the factoring method only works if it can be factored. If it can't be factored, then you can't use the factoring method. So the next method that we're going to do is a method that always works. It's so important it has a name, the quadratic formula. The quadratic formula. This is a formula you can use that, my mind went blank. This is a formula you can use to solve any quadratic equation. You've got to first have the equation written in standard form. So here it is. The solutions of the equation ax squared plus bx plus c equals 0. And we're assuming a is not the number 0, because if it were, we wouldn't have a quadratic equation. We'd have a linear equation. Or given by, if someone came up to you and said, state the quadratic formula, what they're expecting you to say is what I'm about to write after x equals. It's a fraction. None of my blue pens. Negative b plus minus the square root of b squared minus 4ac all over 2a. Negative b plus minus the square root of b squared minus 4ac all over 2a. So this is a formula that will solve any type of quadratic equation. My habit, if I'm just sitting around needing to solve a quadratic equation, my first thoughts are always, can I factor it? Because if the numbers aren't too big and I can factor it pretty easily, great. But if the numbers are large and it takes me a long time to factor it, I skip straight to the quadratic formula. If on a test, if it tells you solve using the quadratic formula, that means it's not going to factor. So you don't need to spend your time trying it. Okay? Let's do number 8. I hope it hasn't already kicked me out. Have I been talking too long? Okay, here's number 8. It says, use the quadratic formula to solve this equation. Let me write it down. Y squared minus 14y equals negative 44. Y squared minus 14y equals negative 44. It says use the quadratic formula to solve this equation. Well, so often students ask, well, can I factor it? Well, theoretically, but I don't think this one's going to factor. As a general rule, if it tells you use the quadratic formula, it's doing you the favor of saying don't bother trying to sit there factoring it. Okay. Now, but regardless of whether you're using the quadratic formula or factoring, you've got to get it in this form here. And you might say, well, wait a minute, what about the square root method? Why aren't you mentioning that? Well, this problem is clearly not in the form something squared equals a number or x squared equals a number. If I can cover up that negative 4 or minus 14y, If we just had y squared equals negative 44, oh yeah, we could use the square root method. Okay? But certainly not here. So it's either factor or quadratic formula. It's not going to factor. So we need to get it in standard form. I'll do that by getting a 0 on the right-hand side. What will I need to do to get that 0? Add 44 to both sides. So here's how I'm writing the equation. Y squared minus 14y, then a plus 44 equals 0. And if I use the quadratic formula, I like to clearly label A equals B equals C equals. A, B, and C, those are numbers. Okay? So let's write out the values for A, B, and C. Don't say Y. What's the coefficient on this Y squared there? That's what A is. What number is right here? 1. Okay? Now B, don't just write 14. It's negative 14. Take that sign with it. And C is positive 44. I'm going to write out the quadratic formula right now. Negative B plus minus the square root of B squared minus 4 times A times C. I'm writing it out. I'll write it down every time I do it today. And by the time I'm finished with this, y'all will be sick of seeing it, and most of y'all will have a good, at least you'll know how to start it. And probably know the bottom too, the minus B and the 2A. And now we just plug into this formula. Okay, so that's what I'm going to do now. Start plugging in. Now, negative B. If I replaced the B with a negative 14, negative 14, what am I about to write right here? Just a positive 14. Negative B really means change the sign on B. Since B is negative, negative B, negative 14, positive 14. Plus minus the square root. And a lot of times I hear students say, you know, my teacher's bad. You skip steps. There's stuff that you should, there's some stuff that it's just easier in the long run if you don't show 1,000,001 steps. The B square, what I suggest you do for the B square is just always either do it in your head or with a calculator. B squared, let's see, what is negative 14 times negative 14? Okay, 196, is that it? So if you can just do it either in your head, and a lot of times B won't be so large. If B were just 4, you'd say 16, 4 times 4. But punch it into your calculator or whatever. So the B squared, I'm going to write 196. Don't get too bogged down with the, all the operations. The 4AC, okay. Well, I guess I'll write, I'll write this one out. Minus 4 times A times C. Times A would be a 1. And what's C? 44? And generally, I will do that bottom just in my head. I'm not going to show the 2 times 1 step. Sometimes showing too many steps makes it harder than it needs to be. The 2 times a, what number am I going to put on the bottom? Okay. A is a 1, so 2 times 1 is just 2. Now, I'm going to simplify under the square root now, and I'll do that with my calculator. Under the square root, I have a 196, then a minus. You can either use the times, or if you want to use parentheses, it's 4. I'm using parentheses for multiplication. 4 times 1 times 44. That gives me a 20 under the square root. So I'm looking at simplifying under the square root symbol. All of that simplifies down to a square root of 20. Oh, let me move my calculator. Or maybe I should have moved the paper. Oh, well. Are y'all caught up with what I'm doing here? On test purposes, I certainly assume you have a calculator, okay? And that's one of the things you just cannot use a cell phone calculator. If my boss found out that I was letting y'all, I'd be in trouble. We've been told over and over and over, even for face-to-face classes. I've told them at times I think that's wrong, especially if I'm sitting there watching you. If you're taking a Chromebook test, I think I would notice if you were sitting there with your phone using your artificial intelligence or what's that called? Photomath. I don't know what I'm talking about. So, if not, then good. Okay? So, okay, y'all know what I'm talking about.
Are you talking about telephones?
Yeah, I'm talking about you doing photomath on your telephone. Okay, but people
That's cheating, by the way.
Yeah, I know.
Oh, okay.
Oh, wait. Yeah, I know. I think they know too. So, okay, square root of 20. Can I simplify that? What perfect square divides evenly into it? 4. I think that's the only one, isn't it? So we think of 20, and this is the stuff we were doing on day 1. So once again, I can get on my soapbox talking about how this stuff builds. We think of 20 as 4 times 5. Oh, okay, good. The square root of 4 is 2, so I have a purple 2 and a square root of 5. So here it is. I'm replacing all of this stuff right here with 2 square root of 5. So I'm going to write it with just one color to make it look a little cleaner. 14 plus minus 2 square root of 5 all over 2. Well, when we were working with imaginary numbers, we saw that if there was an I here, you'd separate to get your final answer. You wouldn't just cancel the 2's. That might be the tempting thing to do.
You can't cancel over addition or subtraction.
Yeah, there can't be any addition or subtraction down here if you're going to cancel like that. But what we can do is, another way you could simplify these, look at the 3 numbers that aren't under the square root. Don't look at the 5. What number other than 1 divides into all 3 of these numbers? 2. So could you imagine just going through and dividing each of those numbers on top and bottom by 2? The 14 divided by 2 would be 7. 2 over 2, they would cancel out, right? Leaving just square root of 5. What would we have on the bottom? And 2 over 2, just a 1, so with nothing, we don't need to write anything there. This was simplified as 7 plus or minus 5, which is the same answer you would get if you separated. Okay? There will be times when, if you did the division versus the separation, you'd be getting two different looking answers. As a general rule of thumb, if there's an I in your answer, here's what wants you to separate. Okay? But we'll see that before it's all over.
I have an idea. I want to do two examples right now.
Can we put this answer in?
Okay. I'll show you my separation process to make sure my simplification process, just to make sure that I always get the correct form they want. So what is that? 7
plus or minus.
Plus or minus, that's down in the hot button, the square root of 5. Okay, and before we go on, any questions there? Okay, let me do this.
I'm going to do this because we're through with that number 8.
Okay. I was going to go to another page.
Well, maybe I won't.
I'm going to do it right here.
I have to say, that's all this writing on this board over here is very aggravating to me. I'm going to try to, all these marks here, and that doesn't mean to be recorded. Well, it ain't coming off.
Okay, I want to look at, let's suppose you were using the quadratic formula and you came up with the following answer. It's a fraction, 8 plus or minus 14i square root of 5 all over 4. And I want to compare it to, notice this one has an I in it. Suppose you had gotten that answer without an I. Suppose you had 8 plus or minus just 14 square roots of 5 all over 4. If you have a fraction of this form, a complex number over an integer, our standard method of reduction was to separate. And that's what we're going to do. We're going to separate the 8 over 4 plus or minus 14i square roots of 5 all over 4. And then we can reduce the fractions individually. 8 divided by 4, that reduces to the integer 2, plus or minus. What can we cancel here? Okay, 14 fourths. Both of those are divisible by 2. 14 divided by 2 is 7. 4 divided by 2 is 2. So we have the integer 2 plus or minus 7i square roots of 5 all over 2. And for a complex answer, this is what they want. They want a plus or minus the I term. Any questions on my logic there? I couldn't hear you. If there's an I on top, separate and cancel individually. If there isn't an I on top, look at this one right here. There's no I. You do what you do what my brother did a moment ago. 2, 14, 2. What's the biggest number that divides evenly into those? 2. So you divide them all by 2. Coming back to this one. 8, 14, and 4. What's the biggest number that divides evenly into 8, 14, and 4? They're all divisible by 2. So I'm going to show my thought process. I'm taking out a 2 from the top. 8 divided by 2 is 4, plus or minus. 14 divided by 2 is 7 square roots of 5. Any questions there?
How did it show that step earlier?
Well, I'm just showing it this time. I won't be showing it, but for this first comparing, I wanted to show it. Any questions on my logic? I took out the 2, because then I can go through, and basically I was dividing. 8 divided by 2 is 4. 14 divided by 2 is 7. 2 will go into 4 2 times. So, here's the answer that you would want if there's no I. Notice they look, considerably different. When there was an I, we wound up with that first term being an integer. When there was no I, all a single fraction. And that's the method that we'll be doing for if there's an I on top, separate and cancel. If there's no I on top, look at the numbers outside of the radical. What number divides evenly into 8, 14, and 4, 2? 8 divided by 2 is 4. 14 divided by 2 is 7. 4 divided by 2 is 2. Any questions there? One more. Okay. 7 plus or minus the square root of 5 all over 2. Okay? I don't see a coefficient on this radical. What do I have as an assumed coefficient there? Just a 1? Hey, I should have asked y'all this. Am I going to split this up like I did this first one?
No,
there's no I, so we're not going to split up. 1, 7, and 2. What's the biggest number that divides evenly into those numbers? Just 1. So this thing here is this. You can't reduce it any further. Y'all understand why I'm not splitting that up? If there had been an I there with that square root, I would have split up.
And if you don't, Pearson will count it wrong. It used to not, but last semester we discovered, if you have an I here and you leave it like this, it was marking it wrong. Right?
If you could put a 1 in front of that square root,
the ones would
that
be
would be okay.
We'll take the 1.
If you typed in 7 plus or minus 1 square root of 5 over 2, that's fine.
Mm-hmm.
Any questions there? Okay, we'll do another one.
Let's get on to number
9.
I just click right there. 9.
I don't think I have enough room. I'm
No,
such a
you
big
got
writer. Okay. I guess that when you win all those penmanship awards the way I did in elementary school, that just made me become a big writer, my big print. This is number 9. Use the quadratic formula to solve the equation 2x squared minus 11x equals 1. Okay.
And I think standard form. Is it in the standard form? Are we ready to?
What am I going to have to do? Okay, so subtract the 1, moving that 1 over, so you have a 2x squared minus 11x. (2x squared minus 11x).
What goes next?
Minus 1. Oh, okay. They didn't know I was waiting for them to say it again. Okay, so we'll identify our A, B, and C values. What's A? 2. B? Okay. And C? So you've already told them to take those signs. Okay. And, okay, why don't we go ahead and rewrite that quadratic formula?
Yeah, I told them we'd rewrite it every time, and by the time class is over, they'll already know negative b plus minus and 2a for the bottom.
They just got to remember the b square root of b squared minus 4ac on top. There. And Okay. Negative b, the opposite of negative 11. What's the opposite of negative 11? A positive 11. Just change the sign on b. That's what that's saying. B squared.
Wait, let's get my calculator. B squared, it's best just to either do it in your head if the numbers are small enough, or use a calculator.
Negative times negative is going to become what? And 11 times 11 is 121, I agree, minus 4 times A times C. A is 2. C is a negative 1. 2 times A, I think we can do that in our head. 4. Oh.
Yeah, 4.
Oh yeah, 4. Yeah, I was looking at that negative 4 times 2 times negative 1. 2 times A, yes, I agree, that's 4. So we have.
Okay, I'm going to start punching this in under the square root. 121 minus
Negative 4 times 2 times negative 1. We can do that in our head. That's what? A plus 8. So we have 121 plus 8. 121 plus 8 is 129.
Yeah, that's what I got with my little calculator.
Oh, the square root of 129.
Where's our list of perfect squares?
Is that a perfect square? No, it's not a perfect square. I'm not sure what the if there is a perfect square other than one that divides it evenly, but I know that that is divisible by 3. Maybe if we divide 129 by 3, we'll get a perfect square. What are we going to get? 129 divided by 3? That is a prime number. I noticed something about Pierce in my lab. When you start getting really messy numbers under the square root, there's a good chance that it can't be reduced. 3 times 43. That's the prime factorization. No perfect square factors. We're just stuck with that 129 under the square root. Are we going to split up our answer? No, because there's not what? An I. Can I take out any common factor? No, that's an assumed 1 there. The only thing that would divide evenly into 1, 11, and 4 is 1. If you don't have a coefficient on front of your square root, there's no way you're going to reduce the thing. Here it is.
And when I type in the answer, go ahead and let me clear out all of that. Move this out of the way.
What do y'all think I'm going to type first? What do you think I'm going to click first? We have that big fraction to enter. I'd use that fraction hot button. I wouldn't try just to use the slash. I have an 11
plus minus. Now, to answer your question, what if you put the 1 in front? It used to let you take, it used to take that. I'm assuming it still does. If not, I'll complain to Pearson about it. And they won't be. Oh, I forgot it. Being recorded. Okay. Let's see. So you don't need to write that 1 there, but if you do, is it going to take it? Yeah. Okay.
Any questions there?
Look at your work.
Okay.
Okay. Going back. What's the next one we want to do?
Number 12.
Once you get number 8, every one of these is quadratic formulas. So 8 through 15 are quadratic formula.
Let me write this one down.
X squared equals 4x minus 20.
Okay. What do y'all think I'm going to do? What do y'all think my first step is going to be? Rewrite it how? But be more specific.
We need a 0 on one side. And I said it at the beginning, it doesn't matter if the 0 is on the
Left or right. But what does matter is you want to make sure A is a positive number.
Always works out better, and I didn't write that there, I was going to come back now and make a note. A, it'll be easier in the long run if A is positive. So write out there somewhere A.
Tony and I like for A to be greater than 0. You can do it with a negative value. You wind up with a negative denominator, and then you have to multiply above and below by a -1 so that you don't have that negative denominator. But if you just make sure that A is always positive, then you don't have to worry about that.
And that's how we'll decide. Are we going to move everything to the left, or are we going to move everything to the right?
Let's see. Did you skip the page? Oh, I skipped a page. I don't know how that happened. I'll go back in a minute. So I guess it'd be less writing if I pick this x squared up and move it over to the right. But that positive 1x squared, when I move it to the right, would become what? Negative. So here's what I have to move terms around. I ask myself, which side should I get the 0 on in a way so that the A value is positive? So with that in mind, I think I need the 0 on the right-hand side. Move these terms over to the left. So I have x squared. What else do I have?
Minus 4x plus 20 equals 0.
And now let's identify our A, B, and C values. A is B, -4. Good. Y'all got the hang of taking that sign real fast. Okay, C, +20. So, rewrite the quadratic formula. The opposite of B, -B, what's that going to become? A +4. B squared, that's something you can do in your head. Negative times negative is, 4 times 4 is, in general, let's just agree, B squared is always going to have what sign? Positive, okay? Because whether B is positive or negative, when you square it, it becomes positive. And then minus 4 times A times C. What goes here? 1, okay. Here, 20, I agree. 2 times A. 2 times 1 is just a 2. I agree.
You do it by hand, and I'll do the little calculator method. The 16 minus 4.
Okay, so don't be saying it aloud because I'm writing. Okay, 4 plus minus the square root of. We have a 16. Oh, I like this problem. -4 times 1 times 20, that's a -80, isn't it? All over 2. 16 minus 80. A -64, I agree. Is that what you got using that calculator of yours?
Yes, even if I'd used my telephone, I would have thought. I don't know why I thought that was.
So 16 minus 80, y'all agree with the negative 64. Oh, this is nice. I like this problem. How can we reduce the square root of negative 64? I can't hear y'all.
Square root of 64 is
8, okay.
The square root of negative is
I.
On this calculator I have right here, if I enter square root of negative 64, this calculator only works with real numbers. Look at the error. Error, non-real answer. That's saying, hey, it's an imaginary number. This calculator can't handle imaginary numbers.
What can I do now? Is this the answer I want to type in? There's an I on top, so what will I do? Okay, so I'm going to separate. In this case, if you factored and canceled, you'd still get the same answer, but that isn't always the case. Put the 4 over 2 plus or minus the 8i over 2, and this reduces very nicely to here 2 plus or minus here 8 divided by 2 is 4, and the I. For the final answer, 2 plus or minus 4i. Any questions there?
Let's see. So, 2 plus or minus 4i.
Now, in the olden days, they didn't used to have that plus minus hot button. Did you mention that to them?
I mentioned
Let
me show you how you used to have to do it.
2 plus 4i, comma, 2 minus 4i.
Which doesn't seem bad unless you're entering one of those messy fractions.
Then it becomes a hassle.
Yeah.
But we used to have to type in the answers individually. I remember the day teaching class at the beginning of the semester. Tony was right next door. I saw that hot button, that plus minus hot button, and we met each other in the hallway, rushing over to tell each other there was a new plus minus hot button. It was a big deal.
We used to teach in 2 rooms without a wall, and we were doing the exact same thing, you know.
And I could hear Tony talking, and Tony could hear me, and it was just this bizarre echo effect going on. Okay, so,
I've got a quick question for you.
yes.
Like on this formula right here, when it's asking you to give the answer, like when we were doing the other ones and it said like solve for S or solve for X, whatever, and then the answer was like X
Equals.
But like on this one, it's just like those parentheses.
The other thing would be just like the parent that say solution set. It might say X equals or solution set.
That means the same thing?
Yes.
The solution set.
That's a good observation.
X equals for number 10.
It's just different programmers.
Okay.
9 says X equals. It just, this isn't like the old-fashioned books where one person wrote the book, so everything was consistent. Here, it's a lot of different programmers writing these problems, and so sometimes X equals, other people, solution set. Okay?
That was a good observation. Did y'all hear what he was saying? Okay.
And you're sort of studying the instructions, and that's what you're supposed to do. I'm reminded of that student that I've mentioned before. Let's do number 14.
Oh, I like number 14 too.
Mm-hmm.
I'm glad I got back over here.
Yeah. Oh, they only took an account. Okay. Oh, okay. Oh, that's that. So this is one of the solution set problems. I mean, the instructions say that, but
I never really paid attention to that. That was a good observation. To me, all I pay attention to is quadratic formula. Can I start identifying A, B, and C, or do I need to move terms? Okay. Now, keeping in mind what I told you earlier, which terms what am I going to move? Do you think I'm going to get the 0 on the left or on the right? I want that. That's what I'm going to do. This thing here, A is now a negative number. You don't want a negative A value, okay? So you just pick it up, move it over to the right. So I have the 0 on the left.
Put a little universal mark.
Oh, I better do that. Yeah. Tony has all these universal marks that I didn't know anything about until we started doing this together. The universal mark for moving that negative 3x square over. Call out what I have right here. Okay. Okay. Let's identify our A, B, and C values. A is 3, I agree. B is negative 7. C is positive 14. And why haven't we ever thought of doing this, Tony? Whoever's sitting here writing, just put the little thing on. I mean, the microphone. We can do it with only one microphone.
Stupidity overwhelms.
I know.
It amazes me.
Okay, I'll rewrite the quadratic formula each time.
See, haven't y'all already memorized the negative b and the over 2a? You know, every time you write it down, you use it, write it down.
I had a colleague once tell me that they couldn't do that. They couldn't write that formula down every time they used the quadratic formula. Okay, negative b. What am I going to have here? Positive 7, I agree.
I think every problem we've done, b has been negative. I think on the next one maybe we'll have a b that's positive.
Has it? Oh, wow, I think you may be right. Well, that's just a coincidence. B will not always be negative. But there it says change the sign, so it became positive 7 plus minus b squared. We can do that in our head. Negative times negative is 7 times 7 is 49. Good. Minus 4 times A times C. A is 3 and C is 14.
Yeah, those numbers are going to get sort of big. This might be a good one too.
Yeah, I was going to say that.
No,
2 times A, they didn't tell me the denominator. 2 times 3 is 6. I agree.
Now, stop for a moment. If we moved everything the other way and kept A as negative, we'd wind up with a negative 6. Way back in the bottom, way back in elementary school, when you first saw fractions and sign numbers, maybe it was in middle school, whenever, the teacher would have said, do not leave a negative number in the bottom of a fraction. So if you do that, you're going to have a whole extra step. Okay? Taking care of that negative in the bottom. Okay, so I'm going to punch in 49 minus 4 times 3 is 12.
Times 14.
That'd be 144 plus 28. Oh, a negative 119.
Okay, so we have a 7 plus or minus. So we have a 7 plus or minus the square root of a negative 119 all over 6. Is 119 a perfect square? That last one we had a perfect square here. No. Can we simplify 119? I don't think we can simplify the square root of 119.
I'm just going through. Here's what my brain is doing. Asking myself, if I divide by a perfect square, does it divide evenly? So here I'm using the calculator just to sort of show my thought process.
119, not
Oops,
116.
okay.
Well, it's still the
119
same thing.
divided by, sorry, messed up. Let me see if I can do it right this time. 119 divided by 9. 119 divided by 4, definitely not.
There is something we're going to have to do to simplify here. There is something we're going to have to do. What is it? Okay, so we'll bring that negative out. So we're going to have 7 plus or minus. That green negative becomes I square roots of 119 all over 6. There was a day and there was a time when my math lab would accept this answer, but
last semester it didn't.
So how about, what are we going to do? I said when we have that fraction over an, sum or difference, a fraction over an integer, we're going to separate 7 over 6 plus or minus I square roots of 119 all over 6.
And just out of curiosity, I'm going to type it in.
Oh, and notice 7 over 6 we can't reduce. The 119's under a square root, so even if there were a common factor, we couldn't reduce with the 6, so we'll stop right there.
It used to take that other answer, so I'm curious. Maybe
Does writing it the second way change the answer at all?
Pardon me, say what?
When you write it the second way, like when you break it down in each individual, is it actually changing the answer?
It's not changing the value at all, but I think of it as driving. When you're driving, my car works just fine. If I go over there and pull out and start driving on the left side of the road, that car will go. I'll give it gas. It's just not standard practice. You're going to get in trouble for driving on those left lanes because here in the U.S. we drive on the right side of the road. The car would still go. Do y'all understand my analogy? It's just not standard practice to leave it right there.
Let's see. But let's
see if they would.
Used to take it. If you did just one big fraction, which is easier to type in, 7
plus minus I square roots of 119.
I square root 119 all over 6. They used to take the answer like that. Let's see if it does. It did.
It did.
Well, I'll be darned.
But I wouldn't count on it always taking it.
Yeah, not all of them do it, unless they've changed it back the way it used to be.
Any questions there?
One of the few cross-canceling multiplying.
I'll let you do that.
Oh, okay. Before we do the next one, I want to review some arithmetic. What student is criticizing their teacher to me? I don't know if my students always want to criticize their teacher to me about the teacher using the word arithmetic and stuff. I had to, arithmetic, algebra begins when you have the variable. As soon as you see the x, that starts algebra. But before then, that's just arithmetic when you're adding, subtracting, multiplying, dividing. When you're multiplying fractions, suppose I want to review multiplying fractions before we do number 14. Suppose we had something like this. 2/3 times, let me see, 17/4. To multiply fractions, the basic rule is just multiply straight across and then cancel if necessary. But there's something else you can do called cross-canceling. You can do this with multiplying fractions. You can't do it when you're adding or subtracting or dividing. But when you're multiplying, do you remember cross-canceling? You could say 2 goes into 4 2 times, and then multiplying straight across, you would have something like 17, not something like, you would have exactly 17 over, what number down here? 6. That's cross-canceling the fractions. It's going to be, it might be significant. Well, it will be significant when we do the next one. Suppose we just had an integer, something like 24 times 11 over 48. Y'all had to multiply that, and you didn't have a calculator. You probably wouldn't want to multiply just straight across. First of all, how could I write this 24 so it's a fraction like this one here? Think of it as 24 over 1. Now let's see, can we do the cross-canceling? What would we have? Okay, 11 over 2 is the answer. 24 goes into 48 2 times. So we'd have 11 over 2. What I'm reviewing here is this idea of cross-canceling. One more. 16 times 15 over 8. How would I multiply those two numbers together? I would think of 16 as 16 over 1. And can I do any cross-canceling? And if so, am I going to have a fraction or just a whole number as my answer? Well, okay, so can I do the cross-canceling? Yeah, so 8 goes into 16 2 times. I'm multiplying straight across. I have 30 over 1. Do I need to write the over 1? No, so just it's a whole number, 30. Tim, you look like you're about to say something. No? Is anyone about to say something? Now, when we look at problem 15, oh yeah, you skipped the page. So, okay. So, looking at number 15. I don't want y'all to panic too much. When you see, number 15 is the last problem in the assignment.
But a little bit of concern and stuff is appropriate at this point. Not really. No.
Well,
This isn't that bad.
it looks bad.
Remember, you can multiply both sides of an equation by anything you want, as long as it's not 0, and still maintain the equality. You can't decide, I'm going to multiply both sides by 0, because you turn everything in the world into 0 equals 0, because 0 times anything is 0. But you can multiply both sides by anything you want, as long as it's not 0.
Now,
My advice to you, figure out something to multiply through by so that you cancel out the fractions
So
that you cross-cancel those fractions that appear.
I was going to have him try to figure that out on the own, but you've already told him. Okay, good. Here's the equation. 1/3 x squared plus 1/15 x minus 1 equals 0. Oops. Theoretically, there's no reason you can't jump into the quadratic formula. Is this in standard form? Yeah. So if you want to say A is 1/3, B is 1 over 15, C is a -1, then you go for it. It's going to be a huge, huge mess. So, as Tim was saying, you can multiply both sides of the equation by any number you want except 0. If you did that, you'd have 0 equals 0.
Can I multiply both sides by 7?
Sure.
But if I multiply 7 by 1/3, if I put a 7 there, will it cancel that 3? You want to multiply by something that's going to cancel every denominator that appears.
Now, which number would cancel the 3? If we multiply by 3? 3, 6, 9, 12, 15, 18, anything like that would cancel the 3. But if you put the 3 there, would it cancel out that entire denominator here? What we're about to do is multiply straight through by, by an integer. I want to multiply straight through by an integer that'll cancel out this bottom denominator. Each of the bottom. Both of the bottom. So multiplying by 3 won't cancel out this one. Does anyone have an idea of what could I multiply straight through by that would get both of these denominators to cancel? Not 3, but maybe 15? Let's try it.
That's the least common multiple. That's what we call it. It's also the least common denominator. If you think about, suppose you had 1/3 and 1/15, and you were going to add those fractions. You multiply through by the least common denominator. It's also called the least common multiple. What I do, if I'm not sure, I start with the biggest denominator. 15 times 1, does the other number go into it? If so, then great. That's what you use. 15 times 2, 30. Well, there are other numbers you could use. You could use 30. You could use 45. If you put a 45 here, would you cancel out the 3? Does 3 go evenly into 45? Say yes. Okay.
Yes,
suppose I put a 45 here. Would the 15 cancel out? But you're getting very big numbers, and you're going to have a lot of reduction at the end. So my advice to you is to use the least common multiple.
By putting this times 15, do y'all see what's about to happen?
By the way, you can't just multiply the denominators. You're having to distribute the 15 over the plus and minus, okay? So not only are you multiplying the fractions by 15, the thing that's not a fraction is still being multiplied by 15. The thing on the right side is being multiplied by 15.
Even the 0 is being multiplied by 15, but that's going to stay 0, isn't it? Anything times 0. But what about over here? Our goal is to get rid of those fractions. Have we done it? 3 goes into 15 5 times. 5 times 1, what's that first one going to be there? 5x squared.
Okay, y'all tell us what the next term's going to be.
Okay.
15, that problem number 15 is bothering me. Because it looks like it's 15 times 15 there.
Okay. Hey, I hadn't realized that problem 15, I have a 15 in it. But see, last year, what was it? Same? Okay. 15 cancels, and we just have a 1x or x. You know what, I'm tempted to write it as 1x so you can clearly see what A and B are. Now, here's the common mistake. So many people are like -1, but no. What should I be writing here? -15.
Even the term without the fraction, you're having to distribute that 15, so the new constant C is a -15, and 0 times 15 stays a 0.
So, you see, we went through a little bit of extra work to avoid having to do A equals 1/3, B equals 1 over 15. Okay? I think this looks a lot better. A is 5. What's B? 1. And what's C? -15. So we multiply through. The rule that we're using is that you can multiply both sides of an equation by any number you want other than 0. So we chose to multiply through by 15 to cancel out both of these denominators. Now let me write out the quadratic formula. -b plus minus the square root of b squared minus 4ac all over 2a. This looks so messy, I'm going to skip a line. So, oh wow. -b, What am I going to write for negative b? Am I going to just put a 1 there or a negative 1? Negative 1. Then plus minus the square root of b squared. You see, if you'd used b as 1 over 15, this would not be a trivial thing. You'd have the fraction 1 over 225 for under that square root. Instead, what are we going to have for b squared? Just a 1. 1 times 1 minus 4 times a times c. A is 5. And c is negative 15. What number will we have in the bottom now? Are y'all caught up with me? Once you get rid of the fractions, it's a pretty basic quadratic formula problem. So value 10, 2 times a is 10. That's right. Tim, you want to grab that calculator and punch that in?
Oh, it's 1, and a negative 20 times a negative 15 is a positive 300. So my mental arithmetic says we're going to have a 301 under the square root.
Okay.
Now let's see if I'm right. 1 minus 4 times 5 times a negative 15. Sure enough, I have a 301.
So let me write it down, replacing all of this with a square root of 301. So we have negative 1.
Are we going to have an I in our answer? No, because the number under the square root is positive.
Mm-hmm. Oh, wow.
Is the square root of 301 a perfect square?
I don't think so. Hit square root of 301 and see what it tells you. Did some of y'all find one of those either little Casio calculators or some of the type where you can punch it in and it'll simplify it for you?
I can go through my head. I know that the square root of 301 can't be reduced.
But,
there's the answer.
About 100, no, 81, no. That square root of 301, do you want us to go through all the perfect squares? It's not going to be reduced. And since it can't be reduced...
Are we going to split up or leave it as it is?
Yep.
Leave it as it is because there's no I. When there's an I, that's when you split up.
Mm-hmm.
Any questions there?
Okay, so big old fraction.
So fraction bar, negative 1 plus minus the square root of 301. And I tab down or click down in the denominator and type a
10. Okay, you know what? Just a, let's say similar question. If y'all don't want to do it all the way, okay, but just tell me,
what are we going to be multiplying through by there to cancel out? What's the smallest number you can use that will cancel out those fractions?
a 10.
A 10?
You could multiply by 10, you could multiply by 20.
Could
30.
you multiply by 100? Would that cancel out the denominators? Yes, but 100 divided by 2, 50x squared. Oh, I wouldn't want to do that. If you use a number that's bigger than necessary, notice, look back at that problem here. We didn't have any, there were no common factors. We weren't able to reduce that number there. If we had used a 30 or a 45, a bigger number, then you would have wound up with some messy number under there that you would have had to then find the perfect square factor, pull it out, factor, and cancel.
But if I multiply straight through by 10, Here's what the equation will look like.
Well, let them tell us. What's the first term going to become? Okay, 5x squared. I agree. What's the second term going to become? Okay, good. Those 10s cancel. The third term?
That's the common mistake. Students will just put -1 and then they're getting it wrong and can't figure out why.
I remember the old test generator that was multiple choice. It would always, one of the wrong answers would always be what you get if they didn't multiply this term. And I kid you not, half the students in the class would get it wrong because they forgot to multiply, and then they'd see what they think is the correct answer and circle it and go on and miss it on the test.
Well, you know what? I'm going to just go ahead for my own peace of mind and finish this problem up. If I don't, I'm afraid y'all won't.
We just did. Is it? Look, look and make sure it's not the same. No, it's not the same numbers. Okay. Good. Okay. C is different.
C is different. So I'll write it down. If I don't finish it, then y'all are going to think I
B is
can't do
different
it.
too. The sign.
But I'll assure you, the little bit of effort multiplying through by 10 makes it a much easier problem than trying to do A equals a half, B equals -1 over 10, C equals -1.
I remember the first time I saw this in homework in an algebra class. My teacher didn't tell me nothing about multiplying and canceling. I went through with those fractions. And I remember, Tony was in a different class back then, and
we were in ninth grade.
We were in ninth grade. You're right. And I had to go and find out what was he doing. Why was he having I having all those fractions to reduce, and Tony wasn't? Well, his teacher had shown him to multiply through by the least common denominator.
Okay.
Keep on going.
So B is -1, so what am I going to write for minus B? +1, then plus minus. Okay, so B squared. -1 times -1 is 1. Minus 4 times A times C. 4 times 5 times a -10. All over 2 times A. What's going to be on the bottom? 10. What are we going to get under there? I do my mental math. This is -20 times -10, so that's 200. 1 plus 200, it'll be square root of 201. I wonder if this problem is rigged so it always ends up with the number 01 right there. I don't know. I mean, I see a pattern, 301, 201, I don't know. Can I simplify square root of 201? No, so 1 plus or minus the square root of 201 all over 10.
In this answer, I know earlier we talked about this one, but does this one have to be there in this answer, or can it not be there?
It can be there, it doesn't have to. Wait.
This one has to be.
This one.
That one has to be there.
That has to be there, because that's the minus B. The one right in front of the square root doesn't have to be. Okay, there's a theoretically...
I was talking about the first one.
Oh, the first...
when you were asking us, the last time you were talking about the first one?
Okay. Like right here, this one's got to be there. Theoretically, there's a 1 here that you can write or not. It'll take it or not. If you wanted to put, I thought you were wanting to put a number in front of the square root.
The reason I'm asking is, it's just a 1 plus or minus. I was wondering if we had to put that 1.
This one you have to. Yes, because you're adding and subtracting. It's when you're multiplying by 1, you don't have to write it. Okay? Did you punch it in?
No.
Mm-hmm. Yes. This one? Okay. Negative B. So B is negative 1. So when I'm plugging in negative, negative 1, that gives you the positive 1.
The opposite of negative 1 becomes a positive.
It might look, let's see, like right here, B was negative 14. So negative B would be a positive 14. It's easier to see when it's not the number 1 right there. Okay? But this one, I got the same way I got this 14 there. Negative B. Change the sign on B. Negative, negative 14. Positive 14. Okay? Any questions there? Oh, did you type that in just so that they'll be confident we got the right answer?
Square root of 201 all over 2.
Uh-oh. What did I do wrong?
1 plus or minus the square root of 201 all over 2.
Oh my gosh.
What
I'm
did you
such an
do?
idiot.
What did
Y'all see what I did wrong? Right there. Isn't that a plus? Right there in front of the 1 over 10? So I wrote a minus. Minus, so that's going to change it.
Oh, so
This minus here, I'm going to start making the changes in red. It should have been a plus, which means this should have been a plus. Oh,
so this should have been what?
so B, okay.
Negative?
So it was actually much more like this
Negative.
one up here
Right.
than I wrote, okay? See, this was a plus here, and I wrote a minus right here.
It should still
So
be
that's going to
minus.
change and put a minus right there. Okay?
I should have thought that.
I should have looked at that and seen. Well, I try to usually once I write a problem down, I try to check back and make sure I didn't miscopy anything. And even if I did, I didn't catch it there. Okay? I wrote minus 1/10 when it should have been a plus. Okay? So on that mistake, well, maybe it's a good time to call it quits. Any questions on here? We're just moving along. One less in a class meeting and stuff. Hopefully you're not getting too far behind because you can't just jump into it. You got to start at number 1. Tim, go back to the assignments. Okay, let's stop it.